Hey, in this video I am going to be working through the notes from Monday, February 8th and Tuesday, February 9th. These notes are going to be divided into two portions. During the first portion I'm going to be talking about how to use the norm CDF function and why do we use it. So just real quick, we're working with the normal distribution. So here's just a quick graphic of the normal distribution. Right down the middle, that's your average or your mean. Sometimes you will be given two values and you're going to be asked to find the percentage of the area represented between those two values. Okay? So the lower of those values I'm going to call LB, and the upper of those values I'm going to call UB. So LB is your lower bound, UB is your upper bound. So your lower bound is going to be the lesser of the two, and your upper bound is going to be the greater of those two. You will need your lower bound, your upper bound, your mean, and your standard deviation in order to solve for the percentage of the area taken up underneath that curve in the shaded region. So just recall, the percentage underneath the entire curve is 100%, and we're only interested in how much of that area is represented here in the shaded region. Okay? So four things: lower bound, upper bound, mean, and standard deviation. Once you have those four things, you can find this unknown percent. Okay? And I will work through a few examples. So right here, the market average price of the fanciest pencil in the whole world is $24,000. The standard deviation is $800. Find the percent of pencils sold in the indicated price range. So I'm going to go through one at a time and identify lower bound, upper bound, mean, and standard deviation. Here, between this value and this value right here, the lower bound is the lesser of the two numbers. The upper bound is the greater of those two numbers. My mean, that's given in the problem, and that's 24,000. The standard deviation, also given in the problem, is $800. Okay? So, how do we find that exact percent? How do you find that percent? Well, you plug it into your calculator. The steps on what you need to do are right here. Just go to the calculate screen, and you're going to type menu, statistics, distributions, and you're going to go to normal CDF, not normal PDF, and push enter. And those are the four things that it's asking for: lower bound, upper bound. This symbol right here, that means stands for mean, and this symbol is, we know that one is standard deviation. So our lower bound is 23,200. The upper bound is 24,800. The mean is 24,000, and the standard deviation is 800. So I push enter, and I'm given a percent. Well, actually, I am given a decimal. Let me zoom in. You're given a decimal. I want us to convert these into percents. So 0.682689. I times it by 100, or I move the decimal 2 places to the right, and your answer is 68.269%. That's your answer to part A. Okay? Let's do another one. Here we're looking for same problem. Now we're looking for between 22,400 and 24,800. Okay, so here's my lower bound, and here's my upper bound. I'll show you a trick real fast. I know that my mean is the same and my standard deviation is the same. So if I go on my calculator, you don't have to go through that whole process again. I'm going to push up until I get to this guy again. I'm going to push enter, and then I'll just change the values that I want. So my new lower bound is 22,400, and my new upper is 24,800. Oh, the upper bound didn't change. The mean is 24,000, and the standard deviation is 800. So while I have this on the screen, I want to fill in this piece right here. So going through those steps calls this norm CDF function. Okay, and what that function wants is 4 numbers. The first one needs to be your LB, or your lower bound, and you put a comma. And the next one needs to be your UB, or upper bound. The third one needs to be your mean, X bar, or mu, however you want to write that. And then the fourth one needs to be your standard deviation. And then you close your parentheses, push enter, and that is your answer for part B. 0.818595. So let me move this 2 decimals to the right. 81.8595, that rounds to 81.860%. 81.860%. And that's your answer for part B. Okay, so I'm going to go through and I'll just label part F. This is your lower bound, and that would be your upper bound. Here is your lower bound in part G, and here's your upper bound in part G. Okay, I'm not going to work through those, but I feel like parts A and B are good examples for you to get F and G. Let's talk about C, D, and E. This one is a little bit different. Part C is a little bit different because we don't have 2 numbers like we did here. Okay? We're just asked to find a range less than some number. Okay? So less than some number. If this is where our number is located, it's asking for this percentage right here. Okay? So in this case, the lower bound is equal to negative infinity. And the upper bound is equal to 23,200. The lower bound is negative infinity all the way down to negative infinity. The upper bound is 23,200. I'm going to make a note up here. Your calculator won't like this. Your calculator is a computer. It's not perfect. It doesn't know how to do this. So instead of giving your calculator infinity or negative infinity, you're going to give the calculator a really big number that acts like negative or positive infinity. So negative infinity, instead of that, we're going to say 9e999, which is scientific notation for 9 times 10 to the 999th power. Excuse me, this should be negative 9, because we're in negative infinity land right now. Okay? And positive infinity is 9e999. And just so you know, that E is located right here to the left of the A. It's the button that looks like E. That'll do the scientific notation for you. Okay, so let's practice. On part C, less than 23,200. So if I go on, you could go through, cycle through, and do it through the menu. That's totally fine. But whenever you plug it in and push enter, this is what it'll look like. So your negative infinity goes right here, and we called that negative 9. Negative 9 E 999, comma, and then our upper bound is 23,200. I have the same mean and the same standard deviation as before. Okay? So if I push enter, I get this decimal. I need to convert it to a percent, so I'm just going to do it the quick and easy way. and you get it is 15.866%. 15.866%. Okay. Part D, less than $25,600. Less than is a key word that your lower bound is negative infinity. So, lower bound, negative infinity. Upper bound, here's your upper bound right here, 25,600. We have the same mean and the same standard deviation as before. Whoa. So, I'm going to just change this. So my lower bound is still negative infinity. My upper bound is now 25,600. So 25,600. There's my mean and there's my standard deviation. So this answer, if we convert that to a percent, so we're on part D, this is 97.725%. There's not really enough room in these notes for everything. I apologize. Okay. More than, part E, more than $26,400. This is a key word that instead of looking at this side, we're looking at this side of things. So my lower bound is going to be this, 26,400. In this case, my upper bound is positive infinity. Okay? So let us change the numbers. Our lower bound, I already forgot, 26,400, 26,400. My upper bound is positive infinity. So positive infinity, I'm going to do, let me zoom out. I just want you to pay attention to my fingers right now, and then I'll show you the screen later. So I'm going to do 9E999. Okay? That's another way of saying positive infinity in your calculator. The mean is still 24,000, and the standard deviation is still 800. So that's it. I push enter, and I get this little number right here, 0.00135. Times that by 100, and I get that this is 0.135%. So that's your answer to part E. So just to summarize, your lines could be, your lower bound and upper bound could be right here. Your lower bound could be negative infinity, and your upper bound could be right here. Or you could have a situation where your lower bound is here, and your upper bound is positive infinity. And here the lower bound was negative infinity, and this was your upper bound. Okay? All you need is the mean, the standard deviation, your lower bound, and your upper bound, and you will get the area. The area that is shaded. Okay? That's what the function norm CDF is for. It gives you that area. In the next video, we're going to be talking about norm INV, in which you're given the area and you're asked to find the lower bound or the upper bound.